Hello everyone, this time we're going to be unpacking while loops. We're going to be looking at what goes on under the hood when you're doing a while loop. So I've got two examples here. The first one is this. I want to print the Fibonacci sequence until the sum in the sequence is greater than 1,000. So let's jump into the code that I have and then we'll unpack that code. So I started my sequence with 1 and 1. And then I've got a nice little print command that just says the sequence is blah and the sum is whatever. So that should print off the very first one right there. Now, my while loops always start with a conditional statement. So it's time for us to actually start looking at what this is going to do. Let's take these two lines of code that are outside the loop, paste them in here. And a while loop is only going to enter the loop if this thing inside happens to be true. So what I'm going to do is sum of x is less than 1,000. I want to see what actually happens with that. So if I do that, I get this print statement that's exactly as expected, and then I get true. Well, good. Okay, so that means the sum of the list that I have right now is less than 1,000. So I am actually going to enter the loop, and then I'm going to actually execute these two lines of code. Okay. So I'm going to wrap this in a print command just so that we see it each time. Okay, so it says true. It actually did work. Now, it's done with those lines of code. It's going to try it again, right? So before I even run those, I have to see, hey, is the sum of the list now still going to match this condition? Is the sum still going to be less than 1,000? And it comes out to be true, so I am going to run this code. Okay, and I run it. That's all good. Okay, same thing again. I'm commenting out the code because I don't know if I'm going to get to it yet. So I'm going to run it. It says true. Okay, so that means I can actually fire that stuff off. Everything seems to be good. And we're basically going to continue on in this pattern, right? I don't know if I'm going to run those two lines of code yet. I'm just going to check, hey, is it true that the sum is less than 1,000? Well, yes, it is. So then let's run those. Okay, and I've run them and play the game over and over and over again. And it keeps saying true because my sum is not getting up to 1,000 quite yet. So let's come back up to here. And now notice I actually got to be above 1,000. Now, why did this last one actually jump up above 1,000? So when it ran the sequence, it built this sequence right here, and it took the sum is 986. So if I run these two highlighted blocks of code on this last line, it actually has a sum of 986. Well, I take the sum, that's less than 1,000. So it tells me to actually append it, print it, and then finally check again. So when I send in a sum of 1596, it finally fails to be true, and it finishes. So there's something that you should probably keep in mind. I could have made a loop here that runs forever. And a while loop has that distinct disadvantage. So let's do this. This is a silly idea. But what if I said, while the sum is greater than 0, do this? Now, the sum to begin with is going to be 2, that's greater than 0, and will always be positive and monotonically increasing. So this will always be true. This is a bad condition, right? So if I press the start button here, it doesn't have any idea what I'm doing. I had to press the stop button to get it to stop. It said keyboard interrupt down here, right? Because it had no sense of actually knowing when to stop. Oops, boom, boom, boom. That's what I wanted. So one thing that I do in while loops is I start a counter. While loops don't naturally have a counter, and I put a range on when my counter is going to stop. So that's basically to stop from having runaway loops. So let's say, hey, if I get to 50 steps through the loop, I really don't want to see the output anyway, so just stop at 50. And then I'm going to increment the counter. Oops, plus equals 1. Now this plus equals, I could have also written as counter equals counter plus 1. So it would have taken 0 and added 1 to it. And the next time through, it would have taken 1 and added 1 to it. The next time it would have taken a 2 and added 1 to it, and so on. Plus equals is a little bit faster way to write that in Python. So now if I run this, while the sum is, oops, less than 1,000 is what I wanted. Okay, and the counter is less than 50. Well, okay, it definitely got there. What if I did less than 5? Okay, let's see here. 0, 1, 2, 3, 4, right? And so I actually got my 5 of them. So the counter is to avoid having runaway loops. With your while loops. Okay, let's look at one more example. And in this particular one, I'm going to look at a sequence. Xn plus 1 is equal to minus a half xn plus 1 with the initial condition of 3. And it can be shown that the equilibrium point is 2/3. I'll let you pause and actually figure that out yourself. But I want to print the value of x and stop when the sequence is within 10 to the minus 5 of the equilibrium. So I start off with just telling it what the initial condition is, x equals 3, and then print it. That's what it did right here. I also started a variable called xeq. This is the equilibrium. And then my while loop says, hey, while the absolute value, numpy.absolute value, I guess I should have an import numpy as np here. I could have done the math absolute value, it would have worked just fine. Right, x minus x equilibrium. So the difference between where I am now and where my equilibrium is, while that is greater than 10 to the minus 5, increment and print. Okay, so let's actually see what's happening here. So I'm going to take all of this, copy, and come down here, paste it. And the first thing I'm going to do is print np.absolute value, x minus x equilibrium is greater than 1e minus 5, 10 to the minus 5. Now this is just going to print off a true or a false. Okay, it's true. Now since it's true, I enter the loop, which means I do those 2 lines of code. Oops. Okay, let's indent those back. There we go. Okay, so it was true. I incremented, I printed the next one. Now I'm going to come back to the beginning of the loop. I'm going to check, hey, is my x now different from the equilibrium by a distance of 10 to the minus 5? Okay, it is still greater than 10 to the minus 5. Well, it should still be. Oops. Yeah, okay, let's just do this. So I check to see if it's greater than 10, the difference is 10 to the minus 5. If it is, I do the loop. I check again. If it is, I do the loop. I check again, and it was, so I do the stuff in the loop. And we keep doing this. I'm going to just put a handful of them in here. Okay, all of these are true. I'm just going to keep copying and pasting. Okay, all of these are still true. And it actually went through a whole bunch of them. Still true. Right? Remember, a loop is to do repetitive tasks very, very quickly. We're getting closer, though. Okay, I finally got down to one that's false. So when it finally gets to reading this particular condition, right? So when I plug in this value and then check the difference between that and the equilibrium, well, let's see, 0.66667, right? Well, that's a difference of 10 to the minus 5. Right, well, that's not greater than 10 to the minus 5 in absolute value, so it's going to say false. It's not going to enter the rest of the loop. It's going to stop. Okay, so I hope this video gave you a sense of what a while loop is doing. And also the other takeaway here, as I scroll back to it, is that in a while loop, you can have runaway loops, so you should probably put in a counter which keeps you from having a runaway loop. I'll let you put a counter into this one on your own.